Welcome to the next part of this series where I'm going through existing tools to deploy Kubernetes on Azure. And in this video, we're going to review Azure Resource Manager. In the previous part, we have looked at Azure CLI to create a Kubernetes cluster on Azure and prepared a service principal for our future deployments. So Azure CLI is a quick way to get container service clusters up and running, but in some cases, we want to have better control over resources. Then Azure Resource Manager templates, they're based on JSON, and they are a way to create a detailed hierarchical specification for resources to be provisioned as a group. So templates can also run in an incremental mode, and there is no need to install any tools in addition to Azure CLI to use Azure Resource Manager. And I will show you the templates for creation of managed Kubernetes cluster on Azure. So Resource Manager configuration usually consists of two primary pieces: the main file with resource definitions and a file with parameter values. So right now we're looking at the main file. I call it kube-deploy.json, and it has parameters, variables, resources, and output sections. And each parameter in the parameters sections has a type, and optionally it has a description, definition of allowed values, and a default value. So parameters can also be of a type secure string if we want to have some sort of sensitive data that shouldn't be displayed. So here we have agent count, agent VM size, admin username, DNS prefix, and then information about SSH key, and service principal ID and client secret. So in variables section, this is the right place where we can perform some adjustments and tricks on parameters. So here we're preparing the DNS prefixes for agents and masters and just grouping the client ID and secret into an object that is called service principal fields. So also when nesting several objects within a variable, it's possible to implement something like branching-like behavior. Then you can get different values for the same parameter depending on what type of value you pass when calling the variable. So resources section tends to be the biggest one because this is where all the resource definitions are. Each resource has a certain API version, name, type, location, and properties. And properties can be unique for various types of resources. For example, so for AKS cluster, we specify info about master and agent VMs, like count, VM size, for example, stuff like this. To make the template deployment return certain values when it's done, we can specify output variables. And this is useful to get values like master fully qualified domain name or SSH command in our case. So the second file, I call it kube-deploy.parameters.json. So here we simply set values for the defined parameters. And in the current example, some sensitive values are fetched directly from the secrets of Azure Key Vault. And very important note here is that if you know how to create and set a secret value in Azure Key Vault and enable access to it from our Resource Manager template, then very good. You can put your own resource ID of your Key Vault here. But if you don't have a Key Vault, and if you would like to find out how to create a Key Vault and how to set secrets for the Key Vault and use it from the Azure Resource Manager template, then jump to the next part of this series where I'm talking about Azure Key Vault, and then come back to this video. So also don't forget to replace the values of parameters in your parameters file with correct ones. So here you can actually see how the usual value is different from fetching a value from Key Vault. So at this point, our template is basically ready. We just need to fill in the parameter value for the Key Vault secret and have the service principal password there. So At this point, we should have an SSH key, the service principal, and the Key Vault secrets ready. And now we can run our Azure Resource Manager templates through the deployment. And let's do that. Let's create a resource group deployment for the new cluster, AZ group deployment create, indicating the resource group name, putting our main template resource definition file as template file. And then it will take a few minutes, but eventually you will see the results. Also, a parameters file we're indicating as a kubedeploy.parameters.json. And then this is basically saying that it should create our deployment. And we will see a bunch of output variables returned. Let's see. Here they are. Here is our master fully qualified domain name and SSH command. So that works. Now, when the cluster is created, to connect to it, we would need to run get credentials command, indicate the name of the cluster and the resource group name. And here, entering the private key password. And it's done, we're connected. Now let's check that we're connected. To check that we're connected, you can install and use the kubectl command. So we're running kubectl config get contexts to see what is our current cluster. And here's the cluster we're connected to. And we can also check some information about our cluster by running kubectl cluster info. So here, master is running and other things also running. So now super useful things that we can do with a cluster is, for example, scaling. Adding nodes to the cluster can be a very common task, and it's very easy to do. For example, AZ AKS scale command is useful, and we can specify agents count parameter. And with the managed Kubernetes cluster, we can also do upgrades. So, for example, if you want your cluster to upgrade to version 1.8.1 from version 1.7.7, you can add a Kubernetes version parameter. So basically, with Azure Resource Manager, you can repeatedly deploy your resources and have confidence that they're deployed in consistent state. And you can also define dependencies between resources and have a correct order. So in the next part, I will show you how to create Azure Key Vault to securely store secrets that we use in our Resource Manager templates. Or if you already watched this video earlier, just skip over to the last part of this series where I'm talking about Terraform. See you there.